All right, so we're going to look at our homework for tonight. I'm going to do a couple of little examples just to get you started. And what I'm going to do is look at the graphs that we have and see if we can read the x-intercepts from these. And for graph F, for example, it looks like I have a -2 and a 0. Those are my intersections with the x-axis. So then I know my x-intercepts are going to be -2, 0, and 0, 0. And what I'm looking for is I'm looking for the x values for which your y's are positive. So these x's would give me positive y's. And then from 0 to infinity, those x's would give me positive y's. And then this region here from -2 to 0, these x's all give me negative y's. So the way that I would write that is I would say that, I'm trying to show you all this at one time, I would say that from -infinity to -2 is going to be a positive or yielding positive y's. Then 0 to infinity are also giving me positive y's, and the negative y's are between -2 and 0. So remember that you're looking for positive and negative intervals of the x values, but you're really looking at where your y's are positive and where your y's are negative. Also, just think about it, where is your graph above the x-axis? Those are positive. Where is your graph below? And those would be your negatives. Now, I want to look at all the different points of intersection, just making sure you get that. So this looks like a -2, what I'm looking at right there, -2, -1, and then I'd have a 1 and a 2. Now, what I want to show you now is your homework from a couple of days ago. You actually had to identify all of these x-intercepts, except for the last two problems. So go ahead, pause the video, and I want you to make sure you understand all these x-intercepts because that'll help you move through the rest of the homework assignment. So pause and come back. Alrighty, welcome back. So you've got all your x-intercepts written down except for the last two functions. So the last two functions are m and n, and let's take a look at these. Now, it looks like I can probably read these off the graph. So that looks like a -4. And you have to notice these are moving by units by 2's. So -4, it looks like roughly. And then maybe that's a -3, and that's a 0. Maybe that's a 1/2, and then that would be a 1, sorry, and that would be a 2. But what I want to do is go ahead and graph this in the calculator and see what it looks like. Okay, so when I go to my graph, I've already kind of put it in there. So you want to do, make sure y'all can see this. So 1/2, and then I have the whole function there. And it looks like this. Okay, so those look to be -4, -3, 0, 1, and 2. So I'm going to go and see on the data table if I can find all those. So -4, -3, 0, 1, and 2. So yes, those are all my x-intercepts. So make sure to write down all of those x-intercepts in tonight's homework in the box here. Or you may actually need to do it down below because you're kind of running out of room. So the x-intercepts here, again, are going to be -4, -3, 0, 1, and 2. Now, when I look at the graph again, the graph has negative y's here, then positive, then negative, then positive, then negative, then positive. So I have to write all those intersections out. So let's do this one together because it's one of the harder ones, and then I'll let you do n on your own. Okay, now, so m, I'm trying to show you all this at one time. So I'm going to do my positive, and then I'm going to do my negative. And I'm just using this space down here. Okay, so positive and negative is what I have. And you could put it in up here as well. So my graph is positive in this region, but it's negative from -infinity to -4. So -infinity to -4, it is below the x-axis. Then from -4 to -3, it's above. So -4 to -3. And this would be a union symbol actually. And then again, it goes negative from -3 to 0. So So the x's from -3 to 0 are giving me y's that are below the x-axis. And from 0 to 1, you're above. And then from 1 to 2, you're below. And then from 2 to infinity, you're above. So you have 3 intervals that are above, and then 3 that are below. Let's make sure that makes sense. So this is below, below, below. So 3 intervals below, above, above, above. So those are all positive. So that is how you're going to do those. Now, looking at the back, I just want to remind you, this is very similar to what we did today in class. And I just want to remind you of function notation. So a function is f of x, and that really just means what? It really just means y. Okay, so for example, I'm just going to do one little problem here. If I evaluate the function and I say f of, let me pick one that's easy to read. Let's do f of 5. This is saying x is equal to 5. Tell me what y is. That's what we're supposed to do in one like that. So when I come over, I go to x of 5, I go up, go back over, and y is a 7. So this would be 7. This means there's a point at 5, 7 on your graph. That is function notation. The other thing that you can do is you can find x. So maybe find x when f of x is equal to, let me come up with one that's pretty easy. Let's go with -5. Okay? So when I say find x when f of x is -5, that's like saying y is -5. So I go to the graph, go to where y is -5, and I go over and find that x. That is an x of -1. So x is equal to -1. In this case, I have a point -1, -5. So I just want to make sure you realize there's 2 different ways to evaluate a function. Well, to think about evaluating functions. If you plug in an x of 5, that means you're trying to find the y. Or if they say f of x is a certain number, they're saying y is actually that number. So this is really saying y is -5. And then you would find the x. And then you have a data point either way. Okay, so hopefully that'll help you with some of this on the back. Just do your best on the back and we'll go over it. This is still kind of in the learning phase of the stuff on the back. So try hard and we'll check in tomorrow. Have a great day.